Cloud is difficult to learn. Cloud is only for techies. Cloud certifications take a long time to do. No, no, and no again. Cloud is easy to learn, and you can do some of the beginner cloud certifications in AWS, Azure, and Google Cloud in less than 2 weeks. How do I know? I'm Ranga Karnam. I'm 10x certified in AWS, Azure, and Google Cloud as well. Our courses are helping thousands of learners do their cloud certifications in AWS, Azure, and Google Cloud. In this series of videos, we'll be focusing on cloud fundamentals. Once you understand the fundamentals of cloud, you will see that learning AWS, Azure, and Google Cloud becomes really, really easy. Are you ready to make learning cloud easy? Let's get started. In this video, let's talk about relational databases. There are a wide variety of relational databases that are present, and each of these varieties is present in each of the clouds as well, AWS, Azure, and Google Cloud. I kind of talk them in terms of the kind of use cases that they are used in. So I would look at relational databases as transactional databases and analytical databases. And inside the transactional databases, I would split them into a couple of categories. I would call them the basic versions and the advanced versions, right? So these are the high-level categories. Let's get into the details and understand each of these categories and each of the databases that are present in different clouds in those categories right now. Let's get started. Now, first of all, what's a relational database? We usually talk about relational databases a lot, right? Relational databases are nothing but databases which use SQL as the query language. And these tables have a very, very well-defined structure. So you have a table definition saying create table. These are the columns. This is the type of the column. And these are the other tables which are present. And you also have very, very well-defined relationships between these tables. For example, this is an order table. This is a customer table. This is a product table. And you have foreign key and primary key relationships as well. Inside the order, you might have a reference to the customer ID. You might have a reference to the product ID. So these are very, very well-defined tables. And you can store data into them, and you can retrieve data from them using SQL. This is kind of the most popular approaches to storing data. If I go back 20 years, then this was almost the only approach which was available to store data. You store it into relational tables and retrieve it back by using SQL. So that's the kind of structure which relational databases provide. Now, relational databases are also provided by each of the cloud platforms. In AWS, the service which is present is called Amazon RDS. So RDS allows you to create a MySQL or an Oracle or a SQL Server database in AWS. And in Azure, it's called Azure Database. So there are multiple Azure database options. You have Azure Database for PostgreSQL, you have Azure Database for MySQL, and also you have Azure Database for MariaDB. And in Google Cloud, the corresponding service is Cloud SQL. So RDS, Azure Database, and Cloud SQL are the cloud services which allow you to create relational databases in the cloud. Now, think about this. What are the advantages that these cloud databases provide you on top of normally running them in your data center? Let's say I would want to set up a database in a data center. Do you think it's easy? The answer is it's not very, very easy, because there are a lot of things that you need to take care of. For example, I would need to take regular backups. Number two, I would want to be able to restore it back to a specific state. Let's say I would want to restore the database. I had a problem, and because of which I would need to restore a database to the state it was a couple of days back. I would also need to ensure availability of the database. I would also need to ensure the scalability of this database as well. I would want to be able to increase storage, or I would want to be able to add more users or add more workloads on that connect to this database. So all these kind of things become the responsibility of somebody who's called the DBA, right? DBAs are responsible for all the operations around the database. And typically, these operations are really, really complex to perform. And these are all some of the biggest advantages of going for the cloud databases. When you go for the cloud database, the operating system where your database runs, the database software itself, all of them, including backups, restoring to a point in past, availability, scalability, all these things become the responsibility of the cloud provider. You can just be responsible for configuring what you would want. Let's look at a few examples, right? So let's take availability of a database as an example, right? How do you ensure high availability for a database? Let's say I have a SQL based database, right? So let's say I have a MySQL database. How do I ensure that it's highly available? The only option that you have to ensure that it's highly available is to have a standby created for it. So you need to set up a standby for it. If you don't have a if you don't have a standby, what would happen? What would happen is if the database goes down, let's say this database went down, your applications which are connecting to it will go down as well. And you don't want that. And that's the reason why you typically go for a standby database. So you'd create a standby database and you'd set up replication, right? So whenever a change is done on this database, you'd want to replicate it to the standby database as well. So that whenever this goes down, you can switch all the applications to connect to the standby database. This would provide you with high availability. Now, let's talk about scalability as well. So what is scalability? Earlier in this series of videos, we talked about two kinds of scalability, right? Scalability is of two types: horizontal scalability and vertical scalability. Vertical scalability is basically increasing the size. Instead of having a smaller virtual machine to run your database, you'd use a larger virtual machine. You can increase the CPU, you can increase the disk size, you can increase the memory, you can increase the disk I/O speed, which is associated with a specific VM. The horizontal scalability, on the other hand, is instead of running one VM for the database, you'd be running multiple VMs of the same size, right? So instead of increasing the size of a VM, you are increasing the number of VMs, right? Whenever we're talking about these simple kind of databases like MySQL, one of the things that you'd see is that you can horizontally scale only for read workloads. You cannot horizontally scale write workloads. What do I mean? What I mean is I cannot say I'll have one instance of the database here, I'll have another instance of the database in here, and I'll be performing write operations to both of these. So I cannot say I'll perform inserts, updates to both of these. You are allowed to perform inserts and updates only to one of these. So either the master or the standby is the one to which you can perform both inserts and updates. However, if you want to have a read capability from the other database, that you can set up. So what you can do is you can say, I would want to create a read replica. So I can create a read replica for this database. And oops, let me get this right. So I can say, I would want to set up a read replica for this. A read replica is a database which you can only read from. So you can have read-based applications. So let's say I have a reporting application. I can have the reporting application read from this database, but I cannot have a transactional application, right? Transactional application is something which makes updates, deletes, inserts, and all that kind of stuff, right? So let's say I have a banking application. I would want to be able to perform transactions. I would want to be able to insert rows. I would want to be able to delete rows and all that stuff, right? So for transactional application, you can only make use of this database. However, if you have reporting applications which are just reading, then you can make use of this database as well. This concept is called read replicas. So when it comes to the traditional SQL databases, you can horizontally scale the reads. So you can distribute reads across multiple instances. However, writes, updates can only be done to one instance at a time, right? So this master database is the only one which you can write to. If this master database is down and you shift all the workloads to the standby database, then you can write to the standby database. But when the master database is up and running, you can only do writes to the master database. So this is one of the biggest limitations of going for a traditional MySQL kind of a database, right? However, even setting up this kind of basic thing is not easy, right? So if you look at it from the perspective of a database administrator, setting up a standby, setting up a read replica, these are not easy things to do. And those are the features that these services provide us with. Both RDS, actually all the three, RDS, Azure Database for MySQL and also PostgreSQL, and Cloud SQL. All of these provide the features for creating standbys and read replicas. All that you need to do is to go into the UI and say, I want this feature, right? So you just go and say, I would want to be able to create a standby in this specific zone. And you can say, I would want to be able to create a read replica in this specific zone. So all that you need to do is very, very simple. Just do some configuration, and this kind of a setup is available for you. So until now, we have been talking about the basic kind of databases which are provided in the cloud. We talked about the relational databases, the basic relational databases, which are used for transactional applications. So whenever I have a banking kind of application, right? So here transactions are very, very important. If I am doing an operation which involve a couple of steps, either all of them should be successful or none of them should be successful. For example, if I'm doing a transaction where I'm transferring $10 from my account to my friend's account, then there are two operations which are involved. One is to reduce $10 from my account and then to add $10 into my friend's account. So these two things should go simultaneously. Either both of them should be successful or none of them should be successful. So these are transactional applications where you have a lot of small updates. You are making a lot of small transactions on the database. And for these kind of databases, typically we go for MySQL, Oracle, SQL Server, and those kind of things. And the corresponding databases in the cloud are RDS, Azure Database, and Cloud SQL. And all of these provide you with horizontal scalability for reads. If you have read workloads, then you can actually create a read replica and scale it up. But they don't provide horizontal scalability for writes. So if you have updates, there is no horizontal scalability. You can set up a standby for high availability, but it does not help you with scaling at all. Now, that's one variety of databases, right? The basic databases for SQL in the cloud. What happened is over the period of last few years, cloud providers came up with new solutions on how you can actually distribute relational workloads, relational transactional workloads using better databases. And these are what I would call as the advanced solutions which are provided by the cloud providers, right? So each of the cloud provider provides you with an advanced way to allow horizontal scaling of writes as well. Earlier, we talked about the fact that the writes cannot be horizontally scaled. You can only write to one instance of the database. You cannot write to the other instances of the database. But what the cloud providers have done is a lot of innovation. And they came up with approaches where you can use the same transactional approach, the same SQL approach. However, you can horizontally scale the writes as well. So you can have multiple copies of the database present, and you can write to any of these instances, and the cloud providers would ensure that the changes would be automatically replicated to other instances. One of the biggest things in supporting writes on multiple databases is that you'd want to be able to sync the changes out to the other databases quickly. If there is any delay in syncing the changes, then if somebody is reading the data from the other database, they actually have the chance to get old data, right? So let's say I'm making an update to this particular database, and this update is not available in these two databases, and somebody is trying to read from here, right? So they would get older data, right? So that's where we talk about something called consistency. Consistency of the data is very, very important, especially in case of transactional applications. You'd want to ensure that you have strong consistency. Once a transaction is committed to one of the copies of the database, you'd want to be able to get the same data from other copies of the databases as well. And these kind of features are provided by some of the advanced databases which are present in each of the cloud platforms. In AWS, the advanced database is Aurora. So this is SQL, relational, transactional. However, this is a global database which can globally distribute the writes on your database, right? So you can actually write to Aurora in multiple regions. And the same feature in Azure is provided by Azure SQL database. Azure SQL database is also a global database. And in Google Cloud, the corresponding database is Cloud Spanner. So for transactional write, if you want horizontal scaling across the globe, then these are the options that you would need to consider. If you just want simple databases, then you can consider these options. Right? If you just want simple transactional relational databases in a specific region, that's when you'd go for basic things. Right? The advanced things are more when you'd want global rights and you want your rights to be distributed as well. In those kind of situations, you'd go for these advanced things. Right? The last category of SQL databases or relational databases are used for data warehousing. Now, what is data warehousing? Let's say I have terabytes of data or petabytes of data. So I have huge volumes of data and I would want to be able to query from this, right? So these databases, if you look at them, they would have very less writes. So you would probably write to this once a day or maybe once a week. So you might actually load data from other databases. But the main operations that we would be performing on this is querying. So you have huge volumes of data from which you would want to generate reports. You'd want to generate intelligence, right? You'd want to be able to analyze and find out patterns. Those are the kinds of things which are called data warehousing databases. If you talk traditionally, the most popular data warehouse a few years back is actually not Terraform, it's actually Teradata. Let me get this right. So it's not Terraform, it's actually Teradata. So Teradata is one of the popular data warehousing tools. Now, if you go over to the cloud platforms also provide alternatives to Teradata. If you want to do data warehousing in the cloud using a SQL relational based database, then in AWS, the corresponding service is called Redshift. So Redshift is the data warehouse in AWS if you want to store the data in a SQL, in a relational kind of a way. And in Azure, the corresponding database is called Synapse Analytics. So Azure Synapse Analytics. This was earlier called Azure Data Warehouse. Now it's called Azure Synapse Analytics. And the corresponding offering in Google Cloud is the favorite data warehouse of mine, which is BigQuery. BigQuery is amazing in the sense that it can be serverless both on the data side and also on the compute side. What do I mean? The same is actually a feature of Synapse Analytics as well. Let's quickly look at the serverless nature of BigQuery and Synapse Analytics as well. So whenever I have lots of data, right? So let's say I would want to store petabytes or exabytes of data. I cannot store it in a single database on a single VM, right? I would need to definitely distribute it into multiple VMs or multiple compute devices. So you need to have the data distributed in a lot of places. And the other thing is you would want to be able to have some kind of centralized way to run queries against this, right? So you'd want to be able to run queries against this database. So you'd want to be able to run queries against petabytes of data. And how can you run queries? To run the queries, you need compute power, right? So you'd need a lot of compute power. There might be a lot of complex queries you'd want to run, and for which you'd need a lot of compute power. What BigQuery and Synapse Analytics do is they separate the storage from compute. So the way you store is separated from the compute. And therefore, as you keep adding data, the data gets distributed. So if I keep increasing the data, what happens is automatically the data gets distributed, and the databases and the corresponding data warehousing service would make sure that the data is organized in a very, very efficient way. So it would take care of partitioning the data to be efficient, and it would also automatically increase the storage. So if I have, let's say, 10 petabytes of data, and I'm adding one more petabyte, all that you need to do is to add the data in, and BigQuery would take care of managing the storage which is underneath. You don't need to worry about the storage which is present. And the same thing happens on the queries as well. Let's say I'm running 10 queries. BigQuery would automatically provision the infrastructure that is needed, the compute which is needed to execute those 10 queries. And later, let's say I'm running 20 queries or 25 queries. It will be able to automatically scale up. And if actually I'm not running any queries at all, then I would not need to pay anything for the compute at all. So you just pay for the compute and the storage that you're making use of. If let's say I have 10 petabytes of data stored, then I would just pay for 10 petabytes. Let's say in addition to 10 petabytes, I'm running 10 queries or 100 queries or 200 queries, you'd pay for both of them, right? So if you, let's say, have 10 petabytes of data, you ran the queries and you don't need that data anymore, you can go ahead and delete the data and you don't need to pay for data at all. So this is kind of serverless in that sense, right? So you pay for what you use. So just the storage you are making use of. So if you are making use of X amount of storage and if you are making use of X amount of compute, you'll only pay for that. And the great thing is you don't need to worry about what happens in the background. You don't need to worry about how the queries are distributed to the databases, how they are executed and all that stuff. That is all taken care of by the cloud service like BigQuery or like Synapse Analytics and things like that. If you go to AWS, in the case of Redshift, you need to create clusters. So there is a little bit of management in here. However, if you want to execute queries in a serverless way, you can also make use of something called AWS Redshift Spectrum. This can help you to fire queries against data which is stored in an object storage in AWS, which is S3. So it does provide a serverless way of actually separating compute and storage, but this is not the this is not a direct feature. You need to go for something called Redshift Spectrum. However, Synapse Analytics and BigQuery provide you serverless storage and compute by default. In this specific video, we talked about a lot of different concepts related to relational databases. We talked about two different use cases related to relational databases. One is transactions, right? Transactions are basically banking applications or things like that, where there are large number of small updates which are being performed, right? So you execute queries to update, delete, and all that stuff. So small amount of large number of small transactions. That's what transactional applications do. The other category of databases which we looked at are the data warehousing. These are reporting applications, analytical applications. These are applications where you are trying to get intelligence for your applications. You're processing petabytes of data. And in the transactional relational databases, we looked at basic ones and advanced ones. When it comes to basic, these are the ways to run, let's say, MySQL or Oracle or PostgreSQL or MariaDB or things like that. So RDS, Azure databases, Cloud SQL. So you go for these kind of things when you just need basic SQL facilities. You're not really looking for very, very high availability. You are okay with good amount of availability. And you are okay with you are okay with writing to one instance of a database. You don't want distributed writes. You want to store your database in one region or one availability zone only. In those kind of situations, you'd go for basic. However, if you'd want to globally distribute your writes, you'd want multi-regional database. In those kind of situations, you can go for the advanced ones like Aurora, Azure SQL Database, and Cloud Spanner. However, if you want to go for data warehousing workloads, huge volumes of data you'd want to query against, in those kinds of situations, you can go for Redshift, Synapse Analytics, and BigQuery. The goal of this video was to give you a high-level overview of the different relational databases which are present in cloud platforms. I'm sure you had a great time watching this video. Do not keep it to yourself. Tell your friends and tell YouTube as well. How do you do that? Like, share, and subscribe. If you're looking to get cloud certified, check out our cloud certification courses in AWS, Azure, and Google Cloud. And do not forget to check out the other videos in this series of videos on cloud fundamentals. If there is a cloud topic that you're feeling it's very, very difficult to understand, do post it in the comments and we will make it simple for you. I'm sure you had a great time watching this video and I'll see you again very, very soon. Until then, here's bye from Ranga at In 28 Minutes. See you soon.